We did quadratic modeling. Oh, we're on number 2. Okay, cool. So, little review. A little bit. Okay, so we are working with this equation right up here. H equals negative 16t squared plus b sub 0 t plus h of 0, where h is the height, t is the time, b sub 0 is the initial velocity, and h of 0 is the initial height. Okay? The negative 16 coefficient is always a given constant because that is gravity. Okay? Unless you're in the metric system, you're going to use negative 9.8 meters per second. Okay? All right, so we found a couple of really important points when we're working with these word problems, right? The vertex, our x, y, is actually our th, where our x is t, or time, and our y is the h-axis, or the height. Okay? This gives us the maximum height, the y-coordinate, and the x-coordinate gives us that time it reaches for that maximum height. Another important point that we're learning is that this x-intercept is the time where it hits the ground. And then we learned about the rate of change here. In this case, it's change of h over the change of t. It's just a slope formula. And we figured it out to be negative 19 feet per second in this problem, but you cannot actually measure. It's like distance. You can't measure speed in negative, right? So that negative sign is just telling us that it's going on the downward slope. The actual velocity is going to be 19 feet per second. All right, are you ready, kids? Let's start number 2. All right, so what happens? What happens if we just drop the object as opposed to launching it? What part of the function from above changes? Okay, think about the difference. Think about the difference of launching a rocket. Quiet down, guys. Think of the difference between launching a rocket and like dropping a pumpkin off the building, right? Top of the building. Okay, so the rocket's going to have an initial velocity, right? Because it's taken off. Okay, so dropping, like it says here, we're going to be dropping an object from a 120-foot building. In our last problem, where was the launch from? 70 feet. So our initial height is going to be different, right? So initial height or what we like to call h of 0 is different. What else is going to be different here? It's not going to be at a speed when we let go, right? So the velocity here is going to be initial velocity represented by v sub 0 is going to be 0. So that's the difference between the two problems. All right. An object is dropped from the roof of a 120-foot building. How long must it fall to hit the ground? So what are we looking for here? How long? So we're looking for time to hit the ground. What is that when we hit the ground? The x-intercept, right? That's going to be when it hits the ground. So let's draw a little sketch here first. Okay, so here's our height. And here's our time or x-axis. Okay, it starts at our initial height of 120. So our initial height is 120. 120. Well, I'm making our function at the same time. Yeah, that's time. So my initial function here, I'm going to use negative 16 because I'm in feet. So negative 16 t squared, trying to find t, plus, again, what's our initial velocity? Our initial velocity is going to be 0. So 0t. So there's my equation. Let's finish our graph. So I'm going to drop this pumpkin. Boom. Splat. And I need to find that time. This time here. Brandy? Make sense? All right. Let's simplify this. Negative 16t squared plus 120. Now, I'm going to do this on the calculator. You guys want to factor this and find out what the x-intercept is? I highly suggest that you use a quadratic formula. It's a decimal. Or we can use a calculator. Okay. Are you ready, kids? I'm going to put in negative 16. I have to use x because we don't have a t. So x squared plus 120. Everybody with me? Graph it. And I don't see a parabola, do you? I see two lines. It actually is a parabola. But we're really, really zoomed in close. So close that we only see two lines. Okay? Now remember, we're at an initial height of 120 feet here. So that's our y coordinate, right? So I'm going to go to our window here. And you got this negative 10, positive 10, 1, negative 10, positive 10. Well, this is my y minimum, my y max. I'm sorry, x min, x max, y min, y max. Now, remember, I told you we're at 120 feet here. So I'm going to put for my y max, I'm going to put at least 120. I'm going to go 140. Okay. I don't need negative 10. In fact, I don't even need this side at all of my parabola. So I might just put this at, I don't know, negative 5. I'm not sure where that x-intercept is, but I know that I'm still not going to need negative numbers on my x-axis. So I'm going to put that at negative 5. I'm going to graph. There's my parabola. Now, I can even blow this, I can even get to this point up. I can blow this up a little bit more here by putting my x max, it looks like it's between 2 or 3. So I'm going to put my x max at 5. I should get a pretty good picture of my parabola, and I do. Okay. Now this is going to become second nature to you working with this window because you have to. because the numbers are so close together, the pixels are making it that way. Remember, this represents 120 now. That, it's just that your calculator can't. Yours may even be thicker. It just can't show it. Well, you could change the scale, but there's no need to. I don't know. You go ahead and count them and let me know, okay? All right, I need to find this x-intercept. Now, I showed you guys this, right? To find this, what's the y value of an x-intercept? 0. So I'm going to go to second trace. I need to find my 0. Hit enter. Okay, it's asking me, are you to the left of that x-intercept? Well, I'm going to make it a little closer. So, yes, enter. I'm to the left of my x-intercept. Now, no, to the left. Now it's asking me, are you to the right of that? Well, you have to go underneath there. So I'm going to hit enter. And it's asking me, do you want to guess between those two bounds of where that x-intercept is? And I want to hit yes, enter again. And it's telling me, well, that point is at 2.74. 2.74. So this intercept is at 2.74, which means it took, it took 2.74 seconds to get there. Okay, what result? Then you didn't have one to the left and one to the right. There's a lot of ways of doing it. Well, that's factoring it. Yeah, if you want to do it that way, that's fine. But the problem is you're going to have to put it in the quadratic formula because it's the decimal. Yes. Because says you are playing basketball in a European league, so we're going to have to use what? The metric system, which is negative 9.8 t squared, right? Okay, so we're going to have to use negative 9.8 because we're dealing with meters. Okay, you release the ball at a height of 1.9 meters. What's that? Initial height, h of 0. With an initial velocity, so you don't even have to like guess what this is. Initial velocity of 8.1 meters per second. So that's our v sub 0 or v naught. How many seconds? So again, we're looking for t. That's why I use s of t. Seconds, get it? S of t. And I'm going to be solving for t. So there it is. Until it reaches the rim, which is 3.05 meters high. So, okay. What's our initial velocity? Plus 8.1 t. And what's our initial height? 1.9. So there's my model. I'm going to draw a little sketch of what's going on. Now here's my height. Here's my time. All right, so I start at initial height of 1.9 meters. Height of a basketball player, right? All right, so he's going to shoot this ball, and it's going to hit the rim or go through the rim of the basketball hoop, right? Then it's going to come down and hit the floor. Okay? So what they're asking is how many seconds until it reaches the rim. So we're looking for this amount of time, correct? Now this is our rim. And it also says the rim is 3.05 meters high. So I know that the vertex, the y coordinate or the h coordinate is 3.05 high. Okay, are you ready, kids? Oh. Use your calculator. Oh, by the way, to put your window back, hit the zoom and then the zoom button here, and then put zoom standard, which is number 6, push number 6, and it puts it back to our default. Did you get that? Okay, so my y equals, I have a new formula to put in, negative 9.8 x squared plus 8.1 x plus 1.9. And I'm going to hit graph. And I could work with this. It's a little small. I might, how about if we just zoom in? Let's try what zoom does. Let's do a zoom in. I want to zoom in right here. Hit enter again. And look at that. A little bit too much, huh? Yeah, let me zoom in on the vertex. Window, oh, zoom standard. And then I'm going to zoom in, maybe on the vertex. Let's see what happens. Zoom in. Oh, zoom in. Enter. Nah, that's not going to help me. I'd rather have my whole thing there. Let me. Yeah, you could use that one. I'm going to change my window though. I'm going to change this, my Y max. Let's see, we're at 3.05, so I'm going to change that to 4. Maybe this I'll put at -5. X max. I don't think it's going to take a whole lot of time, so I'm going to put in 5 seconds. And again, -5 for my X min. Graph it, see what happens. Oh, that's a good one. So you're just going to have to play with the windows until you can work with it. All right. So again, I'm looking for how many seconds it reaches the hoop. So I'm looking for this coordinate right here, right? T or X. What'd you get? I don't know. I haven't figured it out. Okay, so I'm going to hit second trace. I'm going to look for that, the maximum. Okay. Because this is a maximum point. So I'm going to hit enter. There's different ways of doing this too. Okay, again, are we to the left of that point? Well, make sure you're to the left of the vertex. Hit enter. Are you to the right of the vertex? I'm going to hit enter and then enter again. And that point is going to be 0.41, 3.05. How come we're getting a different point here? That should be the same point. I don't understand. What's going on? I'm confused. Riso, what you did was you found this total time here where it hit the floor. That's 1.02 seconds. Okay? But to hit this point, I'm getting 0.413, 0.41, a half a second. I'm finding the vertex, but it just isn't working out because it's saying that my Y value is 3.5. This says it's 3.05. I'm not sure what's going on. I got a feeling they may have screwed that up.